So anyone who wants to start a couple of questions what we may have. Anyway, as Chris said, no, you're all available. They're all available to meet during the breaks.
Check. Please.
Okay.
Please.
Hello. Introduce yourself and then ask for the speaker whom you want to ask a question.
My name is Ashok Saxena. I was MD of HAL. I'm in the manufacturing discipline of aerospace. I was told that the old setup of the machines or the plant machinery can be updated with the help of AI and IoT systems to increase the efficiency of the system as well as the quality. How it can be done? Just because I'm an old timer, I mean, take time to understand.
You have any speaker in mind? Whom do you want to?
Yeah, Tata Consultancy actually.
Huh?
He had addressed this issue. Rashekar ji.
Can you repeat the question?
Yeah, the old plant and machine, not very old, the setup which is existing in various aircraft manufacturing components, okay? Now, in order to upgrade that with the help of artificial intelligence and IoT to improve the efficiency and effectivity, how it can be done?
Okay, I'll take that.
Okay.
There are some systems that...
because plant machinery of aerospace industry is very expensive to replace totally with the modern one.
So there are some systems that are in manufacturing that have been there for a long time, and one of the ones that jumps immediately to mind are injection molding machines, because they tend to be a huge capital investment, 250-ton press, bought many years ago. Nobody wants to upgrade it. So there are scenarios where you can place like a control system to monitor the existing machine, almost spider over the top, and collect data from all the existing sensors. But you need another kind of control device to collate that and then pass that back to either your line controller or maybe an edge controller, and then you start to build your picture of what's actually happening on that machine. Of course, if there's an old machine with no communication interface, then you're going to have to do something like that, because it's got no way of communicating with the outside world. So you need a secondary controller to come in and put over the top. Interestingly, you're not unique. We did the same thing for Intel. Oh yeah, the chip maker. We put a similar system over the top of one of their chip-making machines to manage for quality control, because exactly the same problem.
I got a supplementary question just for a minute. In aerospace, we use a lot of 4-axis and 5-axis CNC machines, okay? Now, it has to talk, it has to interact with a lot of other machines also. IoT, can there be a solution through this artificial intelligence to bring it in the IoT?
Yeah, and you'll see there are many of the machine tool makers are actually making solutions by themselves already. So you probably saw a couple years ago, DMG, they made a Atomos kind of group, which is all about enabling all those CNC machines to start to become useful data providers in the future. But, there are lots of solutions. The Siemens guys are also doing something similar to what we're doing. So, yeah, many guys are doing the same thing. It's a question of actually, what do I want to get from the machine? Okay. And actually, that's probably a little bit more towards what Sal was saying earlier, which is, yeah, of course I can do it digitally, but why am I doing it? What am I actually going to do with this data once I've got it all? Well, maybe you can add something to that.
So, I mean, just to add, we have been doing this in some cases in India itself, and there are more of the shop floors very similar to yours, where you have around 100 CNC machines cutting across various makes. This is the reality, and you can integrate them and digitalize it. So you have a lot of these methodologies to do it. Even if it's an old machine, you have gateway offerings. That is where the ecosystem comes in. And we can get that connected and connect to a cloud where finally, at least that customer was using it more for operational transparency, OEE, and also getting more of ensuring that the uptime of their assets, all those 100 assets are up to date, and that is where they got the biggest advantage.
So the solutions are available, yes, and to be approached by the organizations like your organization, his organization, to get the solutions. Huh?
Yeah, sure.
Okay, thank you.
Mr. P.N. Parikh, I work for Safety Instrumented System. Questions to all the people who have presented smart technology, artificial intelligence, and also mentioned also that system is safe and intrinsically safe, particularly in the first lecture. Question is, do you measure the safety performance of all the smart or artificial intelligence system, something like SEAL 3 or SEAL 4 or something like? So far, has there been any progress done in this line, or is only smart talking?
So was your question related to including safety systems into
It's
the open?
yeah, because in your slide, it indicated one of the bullet point that the system which is likely to be there or is under progress is safe and intrinsically secure. Okay. Now, when you say safe, the performance of safe is required to be sort of, certified that it is SEAL 2, SEAL 3, SEAL 4.
Yeah, okay. So safe and secure, maybe safe was misused there. Within ExxonMobil, we keep our safety instrument systems separate from our distributed control systems. So those will remain separate even when we go into open process automation. Now, not everybody has that same practice, but that's our practice. So we keep our safety systems isolated and separate from our control systems.
How about that same in the robotics? Are the robots given a command when it's likely to be unsafe for the people around or where they are working?
You asked a question about robotics, is that correct, with regard to being safe?
I asked about, there had been incidences where robots have crushed people. There had been loss of life because the robot did not understand properly and it acted it, something like that.
There's a lot of technology going into robotics in terms of safeguarding.
Are the robots SEAL certified? That is a key question.
Oh. It's the application around it that's still certified typically. However, you started over 10 years ago, I believe, a lot of the robotics started to have integrated solutions where they would control they could restrict the envelope that it would follow, so it would have a restricted path. But now, I mean, a lot of the manufacturers of robots are using that in conjunction with people walking into the workspace. So say you walk into a workspace, the robot knows it because maybe it's detected on a laser scanner, or it's a pad, that it's a sensitive pad, and then once you're in that space, the robot has, say, a restricted envelope, and then it can't even come out to your location. Now that's a lot of the evolution in terms of how safety is being incorporated in robotics.
Okay, thank you.
Sorry, I can add some more to that because actually the application of robots and safety, imagine it's like a semicircle. And on this extreme side, you've got robots which are in enclosures. Those are operating at high speed with no human coming into the environment. But as you move more and more to this side, to what you probably know as collaborative robots, then you have no barriers and you have people and the robots interacting directly with each other. Now, there are various stages around that semicircle of different types of safety solution that are being employed. Now, Sal just mentioned about laser scanners for space environment recognition and for pads. Those are all kind of about this position here. But it means a robot typically is running pretty fast, but as soon as somebody breaks into that region, it starts to slow down. And often they will have 2 zones or 3 zones of sensing, and then as you get closer, they become stationary. So high-speed production here, put it in a cell, keep the people away. Interactive production with humans, then you're going to have to accept that your production speed will reduce, but you need to have levels of access. I think SICK released recently a zone scanner with 150 zones because they want to apply robots onto AGVs driving around the factory. So they want to sense where everything is. Over on the other side with the collaborative robot, then you must accept that the collaborative robot will operate very slowly in comparison. Because even when it's moving with the human there, what will happen is the force sensors and the torque sensors in the arm, when it hits the human, it will register that the torque is going up or the force required is going up, and then it will stop. Now, there were also some versions where you put an air skin over the top of the existing robot arm to do the same thing. So there are lots and lots of robot solutions that are SIL rated because of the application scenario that are available today, either to be used as new install or retrofit.
Okay, thank you. Thank you very much.
Round of applause for all the speakers. Thank you.